Dear student, welcome to this session. Today we will discuss large sample test for proportions. Friends, you know that in some cases the data is non-measurable, and whenever the data is non-measurable, so that represents some qualities. So, and in statistics, you know the theory of attributes. So attributes are nothing but the characteristics which are of qualitative in nature. And whenever there is the data which is of qualitative nature, we need to find out the proportions. Suppose there is a village, and in the village there are some males and some females were living, and we know we want to find out what is the proportion of males in a particular locality. So to find out this, we need to find out the proportion value. And whenever we are interested in proportion, we have to take a certain type of items in a particular population. So like how many males are there in a particular locality, or how many healthy persons living in a village. So healthy, male, smoker, so all these are nothing but the qualities of an individual. And to represent these qualities and to find out the representation of these qualities in a particular locality, we are interested in testing population proportion, with a specified value should be taken as P naught. Let us consider the procedure. Now suppose if you take the capital P as the proportion of certain type of items in population, whereas this small n represents the sample size, and X is nothing but the number of items of certain type in N. So that means number of males in a village, and if the sample size is 1000, so out of these 1000, how many males are there? So that is nothing but my proportion value. So generally this P is nothing but X divided by N, and X divided by N stands for the proportion of certain type of items in a sample. So suppose if I say that the population proportion for males is supposed to be 0.5, then this 0.5 value is nothing but my specified value. So this 0.5 is what? So that is my specified value, and in this case my specified value is taken to be 0.5. And now I want to check that whether this population proportion value, which is 0.5, is a representative of a particular sample. So that means what I want to do, so I have to select a village, and in that village I have to take the sample size, and out of this sample size how many males are there, and whether the number of males in my sample is 0.5, then I can say that the sample is the proper representative of the population. So therefore in this proportion test we are using a binomial distribution. So why we are using a binomial distribution? Because there are the two options. So that means either a male is there, or a person is a female person is there. So that means either male or female, either smoker or non-smoker. So either a person is a person can be classified, so it is a dichotomous. So there are two ways, so either male or female. So therefore this X follows a binomial distribution with parameter N and P, and we know that the expectation of X is NP and the variance of X is NPQ. So now find out the unbiased estimate of expectation of P, and expectation of P is nothing but expectation of X upon N, and that will gives us the value capital P. See this derivation, and the variance of P is nothing but PQ divided by N. Once I know the expectation of P and variance of P, so it is easy to find out the standard error of P, and we can easily use the central limit theorem. And you know friends that any test procedure is of 4 steps. Step number 1 is nothing but setting up the hypothesis. So this is my step number 1. The second step is finding the test statistic. The third step is related with critical region, and the fourth one is conclusion about the procedure. So we can start with our test statistic. We can start with the procedure by using hypothesis setting. So what is my hypothesis in this case? My hypothesis in this case is H naught is P equal to P naught versus P which is not equal to P naught. And we know what is expectation of P and variance of P. So now I can calculate easily by using central limit theorem the value of Z. So Z is equal to what? P minus expectation of P divided by standard error of P. And what is expectation of P is capital P, and standard error of P is square root of capital P capital Q divided by N. This follows normal 0, 1. And under H naught, so what is my H naught? My H naught is P is equal to P naught. So suppose if I put the value of P as P naught, then under H naught, P equal to P naught, my test statistic becomes, so this is my revised test statistic. So that is equal to P minus P naught divided by square root of P naught Q naught divided by N, and which follows normal 0, 1. So this is my calculated value of Z. Now what I want to do, I want to compare this calculated value of Z with the table value of Z. So that is my third step. And in third step, I want to find out the critical region. And what is the critical region? Since the test statistic is, so the test procedure is based on two-tailed, so I can take the critical region as the table Z can be calculated by using the formula probability of mod Z is greater than Z alpha by 2 equal to alpha. So alpha is my level of significance. So normally the level of significance is either 1%, 5% or 10%. Generally we are taking this as a 5%. And suppose if my calculated value of Z is greater than table value of Z, the H naught should be rejected, otherwise accepted. So there is one more procedure. So if you input the values to any software like R or MS Excel, so that will gives us a P value. The P value, if the P value is less than alpha, so alpha is my level of significance. If P value is less than alpha, we need to reject H naught, otherwise accept H naught. So this is the test procedure for single sample proportion. So this is the proportion test for single sample. So we will discuss the equality of proportion test, which is based on 2 samples in the next session. Thank you very much.